So when we talk about the nature of roots, we're talking about the number of solutions to a quadratic equation, or in other words, how many times it crosses the x-axis. So when we have this equation here, what we can do is we can solve this with a quadratic equation, with quadratic formula. So I can just plug this in. So I end up with x is equal to negative of negative 2 plus minus square root of negative 2 squared minus 4 times a times c. Okay, and then all divided by 2a. Okay, and when I simplify this, I get plus minus square root of 4 minus 36 is negative 32 all over 2. Now, there seems to be a bit of a problem here, because one thing I do know about square roots is that we cannot square root a negative. So there's no, if that's the area, there's nothing that we square that can give us a square area of negative 32. Anytime we square something, we're going to end up with positive. So we cannot undo this square root. Now there is a complex, what we call a complex solution, but this is getting into imaginary numbers, and we're not in the real number system. There's no solution to this. So what happens then? We don't seem to be able to resolve this. There doesn't seem to be an answer to this equation. Well, what does this equation look like? Okay, so we want to know why the quadratic formula isn't giving us a solution. So to give us a hint, what we can do is graph this, and we can see what the graph of this looks like. Okay, and then we can maybe analyze the graph, and based on the graph, why is it that we're not getting a solution here? Okay, so when I graph this, I plug this into my graphing tool, okay, and when I sketch the graph of this, okay, it looks like what I do know about this has a y-intercept of plus 9, and when I sketch the graph of this, I get a parabola that looks kind of like that. Well, why don't I get a solution? Well, the solution for the quadratic equation occurs along the x-axis. Okay, so it's basically, where does a graph cross that red line? Where is it equal to 0? Okay, so this quadratic equation has no solution, because the graph of this, so the graph of the quadratic parabola does not cross the x-axis. And we know that that's the connection between equations and graphs, is that where the graph crosses the x-axis is where the solution to the where the solution to the equation equals 0 is. And this does not cross that x-axis. It is never equal to 0. So there is no solution, no x's that make this graph cross the x-axis. So this is a problem here. Okay, it's not really a problem, it's just that there's no solution here. So what we say then is there's no real solution. We just say no solution. Okay. Now there are imaginary solutions that if we use the imaginary number system or the complex number system, we can find a solution, but in the real number system, there's no solution. Okay, let's take a look at this one. Let's solve this one by quadratic formula. So plugging it in again, we get x equals negative b plus minus the square root of b squared minus 4 times a times c. Okay, that's all over 2a. Okay, so simplifying this, I get plus minus 144. 16 times 9 is 144, so 144 minus 144 gives us 0. Okay, well, if this is a case, well, I know that this is my vertex here, And I know that my two zeros are going to be symmetrically distributed, but we're going 0 from the vertex to the right, 0 from the vertex left. Well, that means that the solution must be at the vertex. Okay, in fact, there's only one answer that I get here. It's negative 12 over 8. When I simplify that, it's negative 3 over 2. Okay, or negative 1.5. So why does this give us one solution? Well, again, we can look at the shape of this graph to give us an idea. Okay, we can look at the picture of this graph to give us an idea why do we only get one solution. Well, we can probably guess at this in that it has something to do with the vertex, because we know the solution is at the vertex. Okay, so when I sketch a graph of this, there's my solution. My graph is going to look like this. It's kind of a horizontally compressed graph. And the vertex just touches at negative 1.5. Okay, so the solution, why does the quadratic formula only give us one answer? Because the parabola only touches the x-axis at the vertex. Okay, so the shape of the graph does tell us what, it gives us an idea of why we get the solutions that we do. So we can see how many solutions a quadratic equation has from the graph, and not only that, this discriminant, okay, and the discriminant is going to be the inside part of the quadratic formula. That discriminant actually tells us, gives an idea of what types of solutions we have. If we have a discriminant that's negative, well, we can't square root negative, so we have no solution. If the discriminant is equal to 0, we know that we cannot go left or right from the vertex, so we know the solution must be at the vertex. And this discriminant is really key to telling us how many solutions this graph has. And we can also reverse that thinking and say we have an idea what this graph looks like based on the discriminant. Okay, and the number of solutions or the nature's roots is going to be based on the discriminant.